Hello, students. Let's consider the mathematical function f of x is equal to x squared plus 1. What do I want to know? Let's say I want to know, is f of x ever divisible by 3? And that's a good mathematical question. Now, the problem about this is, first of all, I haven't said which numbers I'm dealing with, but when I talk about divisibility, that implies I'm dealing with whole numbers. Otherwise, once you remove 0, everything's divisible by everything. But still, a statement about infinitely many numbers, that's not going to be so easy for us to check in Python. So I could say, let's just check to see if it seems like this is true or false. Let's just check the numbers from 1 to 100. Now, this is not a formal proof, but it is a proof of the statement about what happens given the numbers 1 through 100. So it's not necessarily maybe the proof we want, but it tells us something. So how could we do this? How could we check to see whether this is divisible by 3? So I'm going to check the numbers from 1 to 100, and let's try that. Let's take x squared plus 1 for x in the range of 1 to 101. And I get this long list, and I'm looking at these numbers, not divisible by 3, not divisible by 3, not divisible. But this looks like something I shouldn't have to do by hand. I should be able to get a computer to do this. And oh, look, I have a computer in front of me. So what could I do to maybe help me out here? Well, there's a few things what I could do. What I could do is I could actually just let's take this, and I will take this mod 3. So what I'm doing is I'm dividing by 3 and I'm taking the remainder. And now I can see, do I ever get 0? If I get 0, that means it's sometimes divisible by 3. Otherwise, it's never divisible by 3, at least in the range that I'm looking. And as you see here, the answer is I just got 1 or 2. And now I didn't even get 1 and 2s with repetitions because, one more time, we're dealing with sets. So I don't have to worry about repetition. So this is basically telling me all the possible outcomes, and it's telling me, hey, either the remainder's 1 or the remainder's 2 if I'm dealing with x in the range from 1 to 100. Okay. So what's another way I could do this? Well, another way that I could do this is I could just say, hey, I could ask, is this ever equal to 0? Now, if it's equal to 0, that would mean it's divisible by 3. So let's see what I got here. Now, I took in a set of all the numbers from 1 to 100, and I checked to see if each of them individually was divisible by 3. And I got the set that just has false. So I must have gotten false, 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 because if there was just one true in there, then I would have had a true in my set, right? A set, you're either in the set or you're not in the set. It doesn't matter how many times you appear. So I must have got false, 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 and then Python truncates it down to false. So now I've seen, this is actually a perfectly valid proof that at least for numbers from 1 to 100, you will never have x squared plus 1 be divisible by 3. So let's ask another similar question. Let's ask what happens if I take x squared minus 1 and I try to divide it by 8. So let's say, is x squared minus 1 ever divisible by 8? That's another good question here. So let's see. Well, now, once again, I'm not going to try and go to infinity because my program will keep running. But let's check to see if it's true from the numbers 1 through 100. Okay, so I'm going to take the set of x squared minus 1. I'm going to divide by 8 for x in my range of 1 to 101. And what this is doing is it's giving me all the possible different remainders that I can get if I divide by 8, if I take x squared minus 1 and I divide by 8. And look what I got here. I got 0, 3, and 7. So it does seem that sometimes, at least sometimes, in this range from 1 to 100, it is divisible by 0. As a matter of fact, I could sort of rephrase this. I could write, hey, let's see, true or false. Is x squared minus 1 divisible by 8? And I'm seeing false and true. That means sometimes it's false and sometimes it's true. Okay, that's good to know. Suppose I just wanted to check whether this was true for odds. Now, there's many ways to do this. One way I could do this is I could just use a filter. I could say I'm only going to check the x that are odd. So if x mod 2 is equal to 1, or I could have just typed not x mod 2, but this is fine. So let's check what this does. And oh my gosh, look here. This is telling me that when x is an odd number from 1 to 100, x squared minus 1 is always divisible by 8. It has to happen. So this is actually a perfectly valid proof. It's not a proof that it works for all numbers because we didn't check all numbers, but it's a proof that it works for the first 100 positive integers. Now, as we move on, eventually we're going to get to all and any and some other types of comprehensions. So we won't have to look at these sets in this way. But this isn't a horrible way of figuring out whether a principal is true or false. And when we're doing this sort of thing in Python, when we're testing things out to see if they seem likely to be true or false, we're doing some pretty sophisticated stuff already, even though we haven't gotten that far in the language. This is called experimental mathematics, when you're using a computer to help you see what's true. It might not write the proof for you for all integers, but if you could check that something's true for a certain number of integers, that sort of puts you on the right path mathematically in order to then try to figure out if it's always true. So this is one way that you could sort of play with this by taking sets of true or false and seeing if you get just true, it's always true for numbers in your area. If you get both, that means it's sometimes true and sometimes false. And if you get just false, then it's never true. And that's something that you know how to play with now.